basically you need to implement this function, the timer init, where you pass in the timer, the prescaler, and the period. So if you want to set the timer to any particular tick time and period event, the setup channel that comes for after, we don't even have to do that one either. Enable inter, not. The set enable, yes. That one is just to enable or disable a timer, as in starting or stopping. Everything also is also explained in the assignment. So if you look at the assignment, you'll see that clearly. Then you have a function to set a millisecond tick, and another one to set microsecond tick, and a blocking function to delay for certain amount of ticks, and one for pulling the flag. So basically these 4 functions, 5 with the set enabled, and 7 with the init. So if we go to the assignment, it's all explained here, even with the to-dos for each function. I have to acknowledge there's a little bit of a mistake here, where it says that we assume, maybe just correct this thing right away. That's assignment 7, right? There's a part here where, no, not this one. Oh, this is 2250. Assignment 7. No,
That
chapter
must be
7.
complicated.
Assignment 7 here. Yeah. These should work for any system clock speed. And we showed you that in the previous demos, how to do the math to set 1 millisecond or 1 microsecond tick. Okay. So I'm going to push this right away. Okay, so I do have a demo for this that I just coded with the class early, so I'm going to show it to you guys here. So it's based on the demo that we did last. So demo 24. This should actually be, let me just correct that name.
Although Carlos is already keyed on his phone computer right now.
Yeah, this is this one, right? Okay. So demo 4 is the last demo of the timer in the simple timer. So that one is, this one is going to be used in the library. Okay. So nothing changed here. The same thing, clock, whatever, LED button, although we're not using it. We have 2 defines, one for microsecond ticks and one for blocking. And I'm going to show you here what they mean. So the first thing, if I want to do microsecond ticks, I'm going to set the tick to 1 microsecond, calling this function. Okay. What this function should do, if we go back to the assignment here, configures the timer for a 1 microsecond tick rate. So what you need to do here is to adjust the prescaler and not the ARR. See, this is also wrong. Freaking AI does get everything wrong sometimes. Yeah, it's just the prescaler here, not the ARR. Okay, so I'm gonna correct that later. Not call it timer init either. Let's just correct this right now because. Okay. We don't call the init, we just do that. We don't do ARR at all, just that. And this is correct because this one I corrected it as well. I had to correct the whole thing. I don't even know why I asked you to generate this one. You did it all wrong. This is correct because I also corrected this.
faster than typing all of it. I guess.
Okay, so before you attack this assignment, I will require you to, or highly recommend that you look at this. I added up an item 5 here, and it is talking a little bit about how the shadow registers work. And the thing is, it explains everything in here. It's explained in much detail. So far, we've been writing these values, but we haven't been using this. And this is basically the one line that you need to add when you're initializing your timer. And I explain here why you need this line. And the thing is that when you set the values, let's say for the prescaler and all that, and for the ARR, these get updated after a full run of the timer. So after the timer generates the first update event, so the first run, it will do it with the default values. Basically, the default ARR is what? What is the default value for the auto reload register? This one.
F.
Yeah, it does the full run.
65, 534.
And the default value for this one is 0, meaning that it prescales by 1. So whenever we write values to this thing and enable the timer, we don't notice that, but the first run does it at this rate. And then when it generates the first update, the first rollover, only then your values get updated. Why? Because when you write values into the registers, they go into the shadow registers. And then after the update, they get pushed to the actual registers, okay? But if we want those values to get updated immediately, we need to generate an update event with software. And that happens here, okay? So I'm explaining here in detail why this needs to be done, okay? So make sure you read through that. I even added a memory diagram so you guys can get why. And again, the data flow is summarized here. So make sure you read that before going into the assignment. And again, the assignment is here, assignment 7. Okay? So, we do have a way of making the timer tick at 1 microsecond and as well as making it tick at 1 millisecond. So these are what these two are. So that's why I have this microsecond ticks defined that does this one. When I comment this one out, it does the other one, the milliseconds. After you do that, for these, I did not ask you to create a function because it's so simple. It's just writing the value into the ARR. And depending on if you set this to tick at 1 millisecond or at 1 microsecond, this is going to be 25 milliseconds or 25 microseconds, okay? That is why I hard-coded it here. This is the way I would like you to, I think this is the easiest way we can do this. Now, if blocking is defined, this is if blocking is not defined, we do this, because if we do blocking, then we'll pass in this number in the function, and that's what I'm going to show you. After you do this, you enable the timer. Then, if you're not using the blocking mode, what you're going to do, you're going to pull the flag. And what this does is just going into the status register and pulling the flag with the if that we were doing earlier. And it's returning 1 or 0 depending if the flag is active or not. It has to be cleared inside the function if it's active, okay, for this to work. And then after this is going to toggle the LED. Whereas if it's doing blocking, you're going to block the code here for a certain amount of time.
5 time slices.
But the value gets passed in here now. And why is this? I did tell you in the past that the only times that we require blocking delays is when we're initializing something. For example, if we're initializing the LCD. And when you're dealing with an LCD initialization sequence, you have to insert several delays, and they're not all the same time. So some of them are 25, it says delay here for 25 milliseconds. Then wait for this. Now delay for 100 milliseconds. And that the whole initialization sequence takes that time.
Just to confirm, so would would we know what those values were based off of, say, like the documentation for a particular LCD display?
Yeah, there's an initialization sequence that has all the steps,
Okay.
which is why I want you to have this, because then you can use this with any number of delay ticks. And if you notice, it's delay ticks. Why is it called delay ticks and it's not called delay milliseconds or delay microseconds? Because it depends on how you set the ticks, if it's going to be milliseconds or microseconds.
And then we would most likely need to do some manual configuration if, you know, there like something was happening a little slower, we'd have to insert a slightly larger delay.
I don't see a situation where you have to delay for more than 65 seconds. Yeah, because remember, when you tick in milliseconds, the timer is 16 bits, you can write up to 65,535, which is effectively 65 seconds, right? So that's a lot of time. Yeah. Now, do you have to do this? No. To be honest, you can create your own functions. You can create your, if you really don't like these delay ticks, go ahead and create your delay milliseconds, your delay microseconds. You can use this one as helper functions to your own functions, whatever. Just have something so you can make your life easier for the exam. That is the whole point. Okay? Okay, let's test this. So right now we are making the timer to tick at microseconds. Let's change that. So hopefully this demo is not too confusing because of the defines, but I notice you guys really love the hash defines, so I say, well, if they really like them, let's use them.
Macros are nice.
Yeah, so now we're gonna tick in milliseconds. All right? And then we're gonna insert 25, meaning that we're going to generate an event of 25 milliseconds. And it's going to be non-blocking most likely, because otherwise it wouldn't make sense to write a value here, because then it gets overwritten there. So now we're gonna pull the flag and we're going to toggle when that happens. So we're gonna run this version of the demo, and then we're gonna point to the scope. And this is effectively running at 25 milliseconds. See, I can just go and change the time here to a different number, let's say 125, 60 milliseconds, and it's gonna run perfectly, and I don't have to change anything here. Just this number here. All right? Questions? Oh, you want me to do it? 75 maybe? We have to undo it then after, because then it will get confusing with the comments. So now this thing is sticking at 75. See? It works beautifully. Okay. Now, let's leave it there at 75, or let's change it at 25, just so we keep it consistent. And let's now change it to blocking. Okay, so we're gonna uncomment this one, blocking. And now it's basically going to not do this part, right? Because it doesn't make sense, because we put it in here now as a parameter, okay? And we do the same thing with blocking. And it turns out to be about the same, 25 milliseconds, okay? Blocking, non-blocking. We need to understand the difference between blocking and non-blocking. That's super important. Let's change now this. Let's put it back to non-blocking. So non-blocking means blocking commented out. And we're gonna change the ticks to microseconds. So now what this is gonna do is gonna set the microsecond tick. It's gonna enable the timer, and it's gonna wait for the flag here. Now this is gonna happen every 25 microseconds, not every 25 milliseconds. And obviously, the time is 1,000 times faster. And as you can see there, it's a little shaky, right? But it's around 25, although it has a bit of an overhead there. Okay? Can anybody already kind of think why this could be happening? we're talking microseconds now. And this is the first conclusion that we should come out of this lesson with. In embedded systems, 1 millisecond is a lot of time. A lot of things can happen in 1 millisecond. 1 microsecond is not a lot of time, because we can have a few lines of code that already take 1 microsecond to execute. So when we are at this level, it becomes really relevant how efficient the code that we write. However, when you want to have some sort of like microsecond blocking events, normally, again, let's go back to the LCD sequence, initialization sequence. It could say, at this point, delay for at least 100 microseconds. So if you end up delaying for 110 microseconds, it doesn't really matter, because it always will say just at least this amount. Now, if we want something super accurate, we can accomplish it, but we have to use interrupts. At that point, blocking, non-blocking, anything that's polling won't work. We have to use interrupts, and we'll discuss that by the end of the course. Okay? So at this point, I would say this is good enough. Moreover, I'm going to change now the event to blocking and see what happens. Same 25 microsecond events, blocking. Oh. What did I do? Blocking? Oh, because I took out the microsecond ticks. So microsecond ticks, blocking. Okay, microsecond block. So I made it milliseconds now. That's why. Microsecond ticks, blocking. 27.4.
Yep.
So I have an overhead of about almost 2.5 microseconds. And again, it's fine. I want to make that clear, because I've had students in the past like, oh no, it's not 25. It's okay. It's a blocking delay.
In the exam, if you most 25 and I have 27, you're gonna check me off, right?
The thing is, like, if I ask you to add a blocking delay, I know it's not going to be exactly that. And again, I ask you not to worry about it, because the blocking delays normally are at least this amount.
So you could be plus or minus 5%.
If you want something accurate, at that point, you're using a non-blocking event based on an interrupt. Okay? Not in this case.
Which is infinitely more accurate.
Okay, so let's see if this thing is like a ratio of overhead, or is it like a fixed offset sort of thing. Let's change this event to 125 instead.
So we're going to see if it's about 127 or...
Yeah,
and
127. So it's a little bit of an offset. Okay, that's the overhead.
So
Now,
is that coming from just like a few lines of code that's taking that amount of time to execute?
Yeah, because in this case, in the delay ticks, I have to do more, because in the other one, I configure the value already here. And all I wait is just for the flag to become active. And it says that's in an if. And that's why it was a bit like shaky, because whenever it was happening, then it was not happening, not happening. That's why the time was like fluctuating. Whereas in this one, it's very consistent because it's blocking. Okay?
So it's the amount of time it takes for the delay ticks.
Yeah. And I'm going to give you the same
execute.
sneak peek here. But can we pause the recording?
Can do.
Yeah.